Hey guys, here's a little video to walk you through some of these parametric style equations and their derivatives and how that all relates to everything we've done so far. This first part is going to have us find tangent lines to the parametric curve at a particular point. And since they gave us our x, and our y in terms of t, we kind of need to figure out what t values that are sort of creating this point. So if this is our point xy, well, then x is obviously going to be 3 and y is going to be 0. We can set them equal to those values independently and figure out what t value makes those happen. So if x is going to be 3, well, then t is going to be plus or minus the square root of 3. And if 0 is going to be t cubed minus 3t, well, that's going to actually get us the same thing plus an extra value of 0 here and plus or minus the square root of 3. Now, it doesn't happen at all of these values, because at t equals 0, x doesn't equal 3. At t equals 0, x equals 0. So we can't actually include this one in our evaluation because it doesn't actually satisfy this particular point. So our values are plus or minus the square root of 3, get us the actual point on the curve of 3, 0. Now, if I want to find the equation of a tangent line, of course I need slope. In order to get slope, I need the derivative. But since each of these are defined independently, x is in terms of t and then y is in terms of t, we need to get the derivative independently. So our dx dt is going to be 2t. Our dy dt, let me get that out of there. Our dy dt is 3t squared minus 3. And if the t value is going to be plus or minus the square root of 3, we can actually figure out what our slope is going to be. Well, slope is the same as it always has been, dy dx, but dy is in terms of t, and dx is in terms of t. So our slope is literally going to be dy dt divided by dx dt. So this is going to be 3t squared minus 3 over 2t at t equals plus or minus the square root of 3. So if I plug in positive square root of 3, let's say, our slope at square root of 3 is going to be, it's 3 times 3, so 9 minus 3 is 6 over 2 radical 3, which is 3 over radical 3, which is radical 3. And our slope at negative radical 3 is going to be, the numerator is still going to be 6 because that's squared, but it's going to be negative 2 radical 3. So this basically becomes negative, square root of 3. So there's our two slopes. Our point, of course, is at 3, 0. So to get our tangent lines, we just do it old school. Y minus 0 equals square root of 3, x minus 3. And y equals, y equals negative square root of 3, x minus 3. So those are our two tangent lines at the point 3, 0 for this particular curve defined parametrically. Okay, so again, to get the t values, you just sort of force x to equal what x equals, y to equal y equals. Use the common t value to make sure that you actually get that point to get your slope. And your slope is still old-fashioned dy dx. We just have to do it in terms of, through t instead of through x. Okay, that sort of takes care of the intro, and I'll post another video with the extensions.